Hello everyone, welcome to Explore Hop. For this example, we're asked, is the function below continuous over its domain? And the function we're given is the function f of x equals x squared plus 1 if x is less than or equal to negative 1, x plus 2 if x is greater than negative 1, but less than or equal to 4, and root of x plus 4 if x is greater than 4. In order to determine if this function is continuous over its domain, we need to check if f of x satisfies the definition of continuity for all values of x in its domain. Notice that each of the individual pieces, such as x squared plus 1, x plus 2, and root x plus 4, are continuous within their respective domains. X squared plus 1 and x plus 2 are polynomials which we know are continuous for all values of x. And root x plus 4 is continuous for all values of x greater than 4, since 4 is greater than 0. So the only potential points of discontinuity are at x equals negative 1 and x equals 4, since the function shifts from one definition to another at these points. So we have possible discontinuities at x equals negative 1 and x equals 4. Let's first evaluate f of x at x equals negative 1 and x equals 4. So based on the definition of f of x, we get that f of negative 1 is equal to negative 1 squared plus 1, which is equal to 2. And f of 4 is equal to 4 plus 2, which is equal to 6. Now, we will take the one-sided limits as x approaches negative 1 and 4 from the left and right. So for x equals negative 1, the limit as x approaches negative 1 from the left in the function f of x is equal to the limit as x approaches negative 1 from the left in the function x squared plus 1, which is equal to negative 1 squared plus 1, which is equal to 2. And the limit as x approaches negative 1 from the right in the function f of x is equal to the limit as x approaches negative 1 from the right in x plus 2, which is equal to negative 1 plus 2, which is equal to 1. And since the one-sided limits are not equal to each other, then this means that the limit as x approaches negative 1 in the function f of x does not exist. And this means that the definition of continuity is not satisfied. So f of x is discontinuous at x equals negative 1. And for x equals 4, the limit as x approaches 4 from the left in the function f of x is equal to the limit as x approaches 4 from the left in x plus 2, which is equal to 4 plus 2, which is equal to 6. And the limit as x approaches 4 from the right in the function f of x is equal to the limit as x approaches 4 from the right in root x plus 4, which is equal to root 4 plus 4, which is equal to 2 plus 4, which gives us 6. And since the one-sided limits are equal to each other this time, then the limit as x approaches 4 in the function f of x is equal to 6. Since both of the one-sided limits are equal to 6, and f of 4 is also equal to 6, which means that the limit as x approaches 4 in f of x is also equal to f of 4. So this means that f of x is continuous at x equals 4. So therefore, f of x is continuous at all values of x in its domain except at x equals -1. And that's it for this example. Thank you for joining us. See you in the next lesson.